Okay, so my table is kind of dark, so I can't really see. Okay, but it looks like this is good. All right, so in discussing, so in dealing with any kind of proportion, what you want to keep in mind is that when it's always like about the difference between two lengths, height and width. So on a square, like you're actually seeing on the screen, the panel, the gray panel is a square. The ratio is actually 1:1 in the sense that if this is 1, then this is also 1. So if you're dealing with like a double square, it would be, imagine if this were actually doubling on this side, then the ratio would be 1:2. Okay, so it's always like the length versus the width. That's the ratio. And it's usually expressed as like 1 on one side, and then on the other side would be 1.6180, or in the case of a double square would be like 2. So it'll be 1:2. So among all the proportion, the easiest one to well, the most useful one to use rather is actually the golden ratio, and then the easiest I would say would be the root 2 rectangle. So what we do is we begin with the golden ratio, because the root 2 rectangle would leads us into the root 3, root 4, and ultimately the root 5 rectangle. So what I'm going to do is start with the golden ratio first. Move some out of the way. And I'll just take a piece of paper down. So with the t-square, what you want to do is always writing on this edge, and then you can use that to draw a series of a horizontal lines using a rectangle in conjunction, in conjunction with your t-square, you can draw your series of a vertical lines. So that's how the do-tos are being used, and they will actually allow you to see the horizontal and vertical line kind of very logically. Is why we are doing that. So this portion of the demo, we're doing it on paper so that we could actually see the logic behind it rather than just copy it. So I'm going to take this piece of paper, and on this I will do a golden ratio. Now, when you're doing the golden ratio, what you need to keep in mind is that on any kind of ratio, you always start with like a finite length. So a finite length from here would be from, let's say, here, and I'm just going to draw like a short line, okay? Now, so this is a line of finite length, and then in the later lines, I'll just draw a line, that goes on to the edge of the page, and then we'll figure out where it's going to end later. So right now, I don't know, so I just drew it all the way to the end. So if this is the finite length, then what you can do in the construction of the golden section is that you can take a several things will work. A 45-45 triangle would work, but the compass, I think, allows us to see the concept behind what we're doing, more logically. So take this, right? And then you just swing it down. When you've done that, what you've actually, by taking this, let's call this 1, to here, let's call this 1, what you're doing is creating a 1:1 ratio, which is actually a square. So this is actually a square, constructed using t-square, triangles, and the compass. So in the golden ratio, what you want to keep in mind is that you can take this corner to corner, and you can divide that into 2 by crisscrossing, something that you very likely learned in your VR class already. So now you actually cut it into 2, and after you cut it into 2 from one square, you can use that to create, double square. So this is actually a double square, being like 1 double square and then 2 double square. So let's say if you call half of this 1, and half of this also 1. So this would be 2. So this is, let's say, assume that it's 2 inches, and this is also 2 inches, and that would be 1 inch, and that would be 1 inch. But we're doing it, we're expressing everything in ratio. So from here, if you take this point and this point, and you construct that. Now, if you actually do a diagonals, that would actually take this double square and turn it into 2 triangles. Now, so if this is 1, then again, this would be 2. And now we're going to take this measurement. I'm going to take this measurement, and we're going to swing this down. Okay. Once this is actually swung down, you take this, draw a line going up, and draw a line coming across. Okay, so what you've done now is actually constructed a bigger rectangles in which the measurement from here to here is the same as the measurement from here to here because we created that use the compass. Now, so this is 1, and this is 1, and this is 2 because that a square plus b square equals c square from the Pythagoras theorem. This would be this a square would be 1, b square would be 2, or 4 square, 2 square would be 4, and then c square would be actually the square root of 5. So what you have in here is actually 1 square, 2 square, c square, and I'll just lay it out in the bottom. Okay, so this new dimension is the square root of 5. Okay, so what that really means with this proportion, and what I'll do now is take a marker to darken it so you can see the rectangle more easily.
Wait, I have a question.
Yes?
I looked away because I'm trying to draw it as you draw it. The curve on the very end, not the one in the square part, but in the rectangle part, how did you get that one?
This one?
Yeah.
I took, good question. I took this.
Oh, you put it in the middle of the point? Okay.
Yeah, right in the middle after I cut this in half, and then I swung that down.
Okay, thank you.
But it's good that you asked that because I know that part is tricky. So from here, I have a rectangle. Okay. And on this rectangle, the property of this rectangle is this. I'm going to take a piece of tracing paper, which I took back. Hey, just give me a second. I just need to get my pen and tracing paper. Okay, so what I'm going to do is take a piece of tracing paper and lay this on top to demonstrate the properties of this rectangle. Okay. And then what I'll do is I'll use the black marker again and overlay the rectangles, and then I'll use the red Sharpie marker to demonstrate its property. Okay. Okay. Okay, so I overlaid a bigger rectangle, and you can faintly see that this is actually a square. Now, so what I'm going to do next is to cut a square away from this. So what you want to recognize is that in a, I'm going to use a red marker to demonstrate the property. So what you need to recognize is that in this particular proportion, of which the math actually works out to be 1 plus the square root of 5, again, is from here, square root of 5, and this is 1, and then this is actually 2, and this is square root of 5 because a square, 1, b square, 2 square, 4, equals c square, 5, 1 plus 4, 5, and this is square root of 5 from the Pythagoras theorem. So from there, you have 1 square root of 5 and over 2, which is 1 plus the square root of 5 divided by 2, which is 1.618. It's an irrational number, so just keep going, okay? So the unique property of this proportions is this. Let's call this 1, okay? So 1.6180 over 1 equals 1 over 0.6180. Okay, so that's the math behind it. I mean, you don't really need to remember this, but that's really the math behind it. But what that really means is this: if I were to take this, and let's say I'm just going to draw this across, and then if I take this, you know, and draw this across, what it means is this: if I take the square, away from this rectangle, then what I have left is the same ratio as the whole thing, because 1 plus the square root of 5 over 2 equals 1 to 1.66180. So what that means is that if I take this and actually cut the squares away from it, then this is the same ratio as this after the square is cut away. So if I, from where this is, now if you look at the two diagonal lines, what I'm actually beginning to construct is the dynamic rectangle, which is a technique that you rely on, in all likelihood, rely on in your composition later from today, okay? So where this diagonal meets this vertical line, once I cut that away, I cut away another square. So what that means, again, if this is the rectangle, and then I cut the square away from it, then what I have left is actually the same as the whole. So what that means is that if I take this, and again, whenever a diagonal hit a horizontal and vertical lines, I use that to construct or to find the next proportion, which is when I take this, slide this up, what I have remaining is the same as the half of this, which is the same as the whole. And likewise, if I now take this and cut this away from it, then what I have in here is the same as this, is the same as this, is the same as this, and then lastly is the same as this. And this will work. I mean, at infinitum, you'll always give you the same proportion. So if I cut this square away from it, this is the same as this. And then right here, if I cut this away from it, again, where the diagonal meets now a vertical line, then this is the same as this. And then lastly, if I cut even one more from here, then that will always work. Does that make sense? Okay. So if you look at your handout, the snail configuration came out of this. Okay, so what we're going to do is, I see that now it's actually close to lunchtime anyway, so we're going to stop. And then when we come back, I'll show you the other rectangles, okay? Because we're going to break for lunch in about 10 minutes. Okay. And then, okay, in breakout room and ask for help, right? Can you tell Darren that I'll be there in about 20 minutes? Can one of you, Bailey, can you let Darren know? Okay, thanks. Okay, so you know what? This is too dark for me, so I need to turn the lights back on. Okay, I just want to duplicate the lighting because later I'll be posting this. All right, so what we're going to do now is to go into the root 2 rectangle. So again, always have this writing on this side of the board, and here we go. And I'm going to just take this down. Okay, now just like with the golden ratio, all ratios start with basically finite length line, and then one that is indefinite to start out with, and then we'll see how the finite lines need to relate into the indefinite lines to find a ratio between the two. So what we're going to do now is we'll start with square, and this time I'm going to maybe make everything a little bit smaller. So again, all proportion really begin with a square. So let's take this, and this time I'll draw a smaller line so I can actually use up, I don't really run out of space. And then this time I'm just going to make the line, okay, this long, that should be doable, okay? So from here, I'm going to draw a line that is longer. And now you know what? Now that I'm looking at the screen, I'm gonna make it just a little bit bigger because I think my compass would actually accommodate that. So I'm gonna make that just maybe like a little bit bigger. Okay. I just want to make sure that this is drawn dark enough so that it's visible. Okay. Okay. So this is the lines that I have. Now, so what I want to do from here is that I'm going to take this point and this point, just like in the golden ratio. I'm going to take these 2 points, and I'm going to transfer that to from the height to the width. Having done that, I'm going to take this up. Okay, and this
Wait,
is
Professor.
Can you see?
Professor,
Yeah.
is this still the golden ratio, or is it?
No, this is the root 2 rectangles.
Okay.
So far you find that the construction is still the same as before, and then when it departs from that. So all of them start with a square. So you know what, I'm just going to clean my brush. Okay.
Question.
Go ahead. I'm listening.
Can you like look at what I did so far? Because I'm drawing the curves part for the other thing.
Thank
Yeah,
you.
we let him know.
Huh?
He knows. We let him know.
Okay, thank you. So this is transferred to a square. And then from here, what I'm going to do is I'm going to take this. Okay. So what I'm essentially doing is actually taking a 45-degree line. Okay. And I'm carrying this down. So as you can see, instead of cutting this in half and then swing it down, the primary difference is this is actually simpler. What I'm really doing is taking the diagonal of the square and swinging that down. So what that actually gives me is a root 2 rectangles. And what I'm going to do is this. I'm going to, oh, okay. So what I'm going to do is just sharpen my pencil. Okay, the new one. All right, so once I find the root 2 rectangle, we're going to come back to this. Because from here, I can show you how to construct a root 3 rectangles, which is really now taking the bigger lines, and then we're swinging that down. So one that is swung down, that's a root 3 rectangle. And then the next step, which is to take now the new diagonals and swing that down. And now what I have is a root 4 rectangles, which is actually a double square. Because I don't know if you can tell that this is actually a square. Because this is actually now the square root of 4. So 1 and 2 is a double square. Now the next one, which is somewhat obscure and that you would need to research on your own, is the root 5 rectangle. Okay. Okay. So that's the root 5 rectangle. All right. So now what I'll show you is actually how you can actually go from here, and I'll overlay another sheet of tracing paper so that we can discuss the properties of the various rectangles. So okay. So with this being overlaid, now let me ask you, when you look at this, is the screen too light or is it too dark? Can you see, or should it be darker?
I can see like the lines you drew, but if you drew curves, like I can't see.
So this is too light. Okay, let me turn off the light there, okay? Okay. Is this a bit better? Kind of? Okay, I'll overlay that with a Sharpie marker then, okay? And that will make it clearer. So from here, what I'm going to do is start with showing you the root 2 rectangles and what it's being used for. Okay, so if I take this, the root 2 rectangle, and I'm going to cut it this time in half. What I ended up having, if I were to cut this in half, is the ratio of this. If this is 1, and this is actually by taking the diagonal of the square and dropping it down, so then the ratio from here to here would be 1 to 1.414, because what I'm dropping down is actually the square root of 2, seeing that this is 1, this is 1, this is the square root of 2. because a squared plus b squared equals c squared. So this is 1 to 1.414. So unlike the golden ratio, when I cut this in half, rather than taking a square away, what you have is actually a proportion of a half rectangle, of which the proportion, meaning from here to here to from here to here, is the same as this proportion from here to here and here to here. So the proportion of half of the rectangle is really the same as the entire rectangle. So what that really means is that if this is actually, let's say, in a book form, then whether if I take the book closed or opens, I really have the same proportion. Does that make sense? Okay. So because of that, what I can actually do is I could actually keep dividing this. Oh, I see. So I could actually keep dividing this so that if I take, oh, you know what? I'll take a red marker, that makes it easier. So if I take this and cut this, I would end up having, again, a subdivision of which the quarter now of the rectangle is the same proportion as the half and is the same as the whole. So what I'll actually do here, I would even construct, let's see. No, I'm going to take this and I'm going to take this. I'm just going to cut this into a square, okay, a rectangle. So once I cut this, then where the bicep would give me this, 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 yes, like even this, okay. So as you can see, each of these subdivision allows me to have a rectangle that is the same as the bigger ones. Does that make sense? Okay, so that's what the root 2 rectangle is based on. So if you're doing a root 2 rectangles, this is what you should keep in mind, which is that the major landmark of a root 2 rectangle would be what happens if you keep cutting it into halves. So that's the root 2, and then what I'll do now is from here, we'll go back to this page. Okay. Okay, and in the next step, okay, so in the next step, what I'm going to do is I'm going to cut this down into cutting out just the with 3 rectangles. Square, root 2, and root 3. So this is the root 3 rectangle. Now what I'm going to do is overlay a new piece of paper. Okay. Hey, kitty, come on. Oh, no, you don't. No, you don't. Okay. All right. So I'm going to take this. So I'm just going to mark the corner. I know it's hard to see, so I'll just mark the corner. And you know what? I'll just use this side. It makes it easier for you to see. Okay. So I'm just going to mark the corner. Okay. And I'll connect these with a red marker. Okay, so this is actually the with 3 rectangles. And then from here, you can take this, and what you want to do is take this diagonal and line it up with this diagonal. So you're really taking this and then just moving it here, okay? So from here, I'm gonna mark this already, mark this, and mark this, okay. So with these, right, so with these, I'm gonna connect the dots. So once you have that, it's so once you have that, what you ended up having is these 2 shapes, and all you need to do is connect these 2 points. But to illustrate the principles, those points actually would line up also with the with 3 rectangles. So you're basically lining up the diagonals of the with 3 rectangles, and so this is the missing piece, and I can even draw this in so you see the rectangles. Okay, so now what you've actually constructed is a hexagon of which all these sides are equal to each other. Does that make sense? Okay, I think this one maybe it takes a little bit while to figure it out. So it's something that you can, give it a try, see if that works for you. All right. Is there any question? This is something that you find in like Islamic tiles, as I mentioned earlier. Okay. So if you don't have any questions, I'll put you back into the rooms. Are we good? Okay.